So my name is Steven Sims. I am the curriculum lead at SANS Institute for Offensive Operations, so all things offensive, hacking, all of that space. I also have been a vulnerability researcher and exploit developer for as long as I can remember, selling exploits, writing exploits to ethical buyers, of course. So a lot of background in the offensive space, but also, of course, in the defensive side of the house as well. And I'll let Eric introduce himself real quick.
Thanks. My name is Eric van Buggenhout, which I said this last year as well. It sounds horrible in English. I'm Belgian, right? So it's a Dutch, Flemish last name. I work at a company called Enviso. What we do there is basically cybersecurity services, ranging from consulting to managed services, a bit of everything, if you will. And then next to that, I also, well, that's actually where I met Steve. Many, many years ago when I was still young and handsome. I could pick one of the two, right? I don't know if it's one of the two. It's probably, maybe it's none of the two, who knows? But that's where I met Steve, and then I got into teaching for SANS, authoring courseware. I'm now the course author for 599 and 699, which is basically the purple team courses of SANS. So very applicable to the topic. I like everything which is about not necessarily rocket science, but doing things more effectively and more efficiently, and that's really what this is all about. So thanks.
Yeah, so again, as I said, I work a lot in the offensive space for quite a long time, and I remember as far back as I can remember, the offensive side of the house when you work at an organization, at least, again, back at that time, still oftentimes today, was like a group of people in a separate room, usually with the kilts and the red hair and all that kind of stuff, and not really communicating so much with the defensive side of the house. So when I first got into IT in general, I was a network engineer, and I was a sysadmin for a while, and I remember seeing the security folks, and I always wanted to be part of the team, but it was hard to kind of get your way in, especially back then, because the teams weren't that big. But my point is that it was a different reporting hierarchy or structure, org chart, right? You've got managers of the offensive side, you've got managers on the defensive side, and all the IT systems, and the communication was lacking, which is my point. So we're trying to accomplish the same goal, but we're not communicating very well. We're trying to protect the organization, our customers, but we're not talking to each other. So we're probably duplicating efforts and not being as efficient and effective as we could be. So in this session, we are going to do a bit of a recap from what we talked about last year, and then we're going to be getting a lot more advanced in this one and getting into some interesting modern examples. So we've broken it up into a few different sections. We'll start off with a quick intro as to what this all is. We'll talk about the problem statement that we're trying to come up with good answers for. Then looking into the future, how, of course, automation and AI does, in fact, play a role. And then hopefully we'll have some time at the end for some questions. Regardless, we'll hang out in the hall if we get kicked out of here, and we can chat with you out there. All right, so introduction. Quick definitions, just want to go over so we're all on the same page. And with a lot of things in this space, subjectivity is there. One name can have many meanings to different people. But just to set some ground, the kind of rules or expectations or definition, pen testing, historically, like when it first came out, we define a scope. We have rules that we need to follow. What time of day are we going to do the testing? What systems are we allowed to touch? Which ones are we not allowed to touch? We need to avoid scope creep. We need to have insurance potentially, depending if we have customers or not. And then we go and do our thing, and then we write up a nice report, and then we hand this report over to the defensive side or whoever the requesters are. We might put a little bit of recommendations in there or some suggestions around mitigations, but we don't typically hang out. We go away, and then maybe you invite us back to try it again after you've implemented some of the defensive recommendations that we've made to try to make our life more difficult the next time. And then it starts to accelerate. We have different technologies, different techniques that have come out. Like red teaming is something that blew up, right? And a lot of organizations will have ongoing penetration testing, and then they'll have like maybe an annual red team. And again, with the penetration testing side of the house, one of the limitations that we often have is that scope. There was a XKCD comic, if you're familiar. It was like a sketch, and it was a medieval castle. And the castle had like a hole blown up, and then the side of the wall, like it was all blown up. The wall was down. The guards were sleeping or drunk and passed out. The moat was dry. The drawbridge was down. Like just problem after problem. And then high up in the tower, there's bars on the window, and there's a little circle around the window, and it says, that's the pen test scope. You see the problem, right? If you limit our scope, how are we going to be able to demonstrate what a real attacker is going to look like if they were to attack you or get into your organization? So red teaming is supposed to be a way where we can be a bit less constrained with that scope, where we maybe don't tell you that we're coming. Only the requester of this testing knows that we're coming, because it's also known, if you're a pen tester, that a lot of times when admins or someone else hear that you might be coming in to do a test, all of a sudden systems are unreachable because they turn them off or disable services because they want the environment to look better than it really is. And what I learned a lot of times historically is that many requesters of penetration tests, they really don't want a penetration test. They just want you to check a box and go away so they can pass some kind of audit or satisfy some regulatory requirements. I don't want to do testing for a company that doesn't really want me to do what I'm good at. So with red teaming, we're typically going to do something called adversary emulation oftentimes. We're really testing your SOC. We're testing your defensive capabilities to see, do you detect us? Do you prevent us maybe? How's your incident response? How does your SOC detect what we're doing and handle it? And again, the response. There's an old saying out there you may have heard that is, prevention is ideal, but detection is a must. And then detection without response obviously has little value as well, because you're just watching. Of course we want to prevent, but we at least need to detect. So again, adversary emulation. We might identify different APT groups out there that have different TTPs, and we want to come at your organization emulating one of these adversaries, especially ones that are more targeted to your vertical market, your industry. So there's lots of different APT groups out there, Fuzzy Bear and APT28, and you've probably heard a lot of them. They all use very similar TTPs, and we can bundle these things together to do an adversary emulation campaign. So I'm not telling you, obviously, anything you probably don't already know. But again, we're trying to define things and get onto the same understanding and definition so we can go forward. So then we've got the blue side of the house, of course, which the people doing the real work, like, offense is fun. You get to come in and knock a bunch of stuff down, but who's going to stay behind and clean things up and make it stronger and retrofit the organization? So back to my point, red and blue historically have not communicated very well, but as I mentioned, we're trying to solve the same goals. So how do we improve this? I remember it was right before COVID at SANS, we had our very first Purple Team Summit. And it was really great turnout. You were there, right?
Yeah.
It was really, really great turnout. And Eric and I were the two authors that put together the first Purple Teaming course at the SANS Institute. And the whole reason that me personally, I had this idea of writing a class like that is because I teach pen testing and hacking courses, exploit dev courses. And I would always do this thing. I'd have like 30 students in the room. And I'd say, how many of you are offensive and do hacking and pen testing? And only typically a third of the room would raise their hands, and I would say, so how many of you are defenders? And most of the hands would go up in the room, and I found that fascinating, because here is the offense informing defense side that we hear about. This is defenders coming to the offensive people to understand how we do our thing so that they can go back and they can try and improve their defenses. So doesn't it make sense then? Because here's another thing that would happen. I'd show a technique. Here's how you hack OSPF routing protocol and inject routes, and you can control the entire routing domain. And isn't it amazing? And then somebody raised their hand and say, well, how do I prevent that from happening? I'm like, oh, it's not a defensive class. We don't talk about such things. But that's what they need. That's what they needed, right? So we absolutely would do well by having a course, or just in general at an organization working together. So that's kind of how the Purple Team course came to fruition. One great example of that we'll see pretty soon is with a well-known mitigation you may have heard of called Credential Guard. I'll talk more about it in a moment, but it gives us it's a great example for me to explain kind of what purple teaming is put into action. There's different levels of it as well that we'll get into. So we've got level 1, level 2, level 3. Like, how do I get started? First off, you got to break down the communication barriers. You got to get the ego out of the way if there is ego. There's no room for ego. Thankfully, it's gotten a lot better over the years. It used to be awful in offensive security space. I don't know where the ego came from, but it needed to go, and thankfully it's gotten a lot better. So if you want to get started, of course, you can see on the slide here, we can We can add some member of the blue team to offensive meetings maybe so they can hear what we're doing. Or we can go attend some of the blue side of the house. One thing we want to start doing here is this concept, and I've heard managers say this a lot, and no offense to managers, I'm talking about non-technical managers that maybe don't have a background in security. And they say something like, well, we want to pen test. No, of course you don't get to know what our defensive capabilities or controls look like. No, you don't get to see our source code. We want it to be a true outsider, opaque box style hack. Like, you don't get access to our source code. And the thing you gotta explain is, give me enough time. We've got these things called disassemblers and decompilers, and we can recover your source code or at least get pretty close to it. That's just gonna take me longer. Same thing with something you may have heard of called fuzzing or fuzz testing, dynamic analysis. This is where we go and understand what the RFCs look like for network protocols and applications, or we understand the file formats for things like PDF documents. And we study them to try and think about all the ways that a developer could have made a mistake when writing the code to support whatever network application or protocol needs to do, right? And then we build up these test cases. We try to send malformed input or create malformed file formats with the goal of crashing the application to see if it's got vulnerabilities in it. Not all bugs are vulnerabilities, but we want to be able to determine if it is a vulnerable condition that we could potentially weaponize. So back to my point, give me enough time, I'll be able to recover all this stuff. So why not just give it to me up front? Like, you're getting a way better deal because we're making much better use of our time. Then I can compile things and instrument them, which means like put monitoring into the application when it's compiled so we can really see what's going on inside the binary and what kind of code coverage depth that we're getting. It's about saving time and improving the quality of our testing, because again, we'll figure this out eventually. Same thing with just take the code out of it. A penetration test against an organization. Why hide from me the fact that you're using one solution versus another solution? Because we'll be able to find this out eventually. I remember, I've heard it from multiple people, it's kind of funny, where there was this one breach in New York City. It was a bank, and the FBI was involved, and some other organizations as well, with regard to law enforcement and incident response. And they determined that the network diagrams and the IP address allocation pools and such was better documented by the attackers who broke into the organization than the network diagrams the company had. If you've ever worked, any network engineers in here? Or someone in a past life, you go to a company and you say, let me see your network diagrams, let me see your IP allocations, is it good? No, it looks like somebody put a magician's hat and put every possible CIDR block or IP address allocation and just started throwing them out there. Who needs more IP? And there's no aggregation, no summarization. It's messy. So tell me what I need to know, and we can improve these things. But back to like level 1, we can start by having some meetings. We can start by being present in conversations. We can start by me, the pen tester, telling you, the defender, here are the techniques I'm going to use in my upcoming pen test. These are techniques that are always good for me. They work often. So you should probably be aware of that and keep an eye out for it. And start building detection rules for it. And then we can talk about how we fix this thing. And then we get into level 2, we can use collaboration tools and such, like Vector, if you've seen that before. We talked a bit about that last year in our presentation. And then, of course, we get all the way over to the right, and that's more about what we're going to get into today with like breach, attack simulation and such, and automation. That's the big one. How do we automate this stuff and leverage LLMs and have agents that can do consumption of things like PDF documents and other threat intel to automate, dynamically do this for us? So breach, attack simulation tooling, just an example. You've probably seen diagrams like this with Gartner before, about the hype life cycle and such. Like, I'll give you a good analogy. Crypto, or who doesn't? A few years ago, right? It was all about crypto. And you've had blockchain technology, smart contracts, and Bitcoin was there for the longest time, and you have other currencies with utility behind them, meaning they're actually useful, like Ethereum. Even Monero, love it or hate it, it's got utility because people on the darknet use it for transactions and such, and laundering and buying controlled substances. So you have all of these coins that came out, Dogecoin and all this other tech, everybody was doing, we saw it, you get my point. The coins were coming out, the technology was coming out, everybody had blockchain, smart contracts, and the hype was going insane. People were getting rich off of coins that made no sense at all. And then people started doing rug pulls and scams and exit scams. And eventually we get over to the right, we get to like plateau land. We level off and we find out what's useful. Once we have that peak and then that dip and then we go back up and level out. The same thing is here with regard to offense and defense and automation and all of the things. I remember when I first heard about, and don't worry, Eric's going to get a chance to talk. He's doing like more of the second half. I'm like, why is he just standing there? So
It's good, it's fine.
he did this to me
It's
last
pretty
year, though.
comfortable.
If you remember last year, he did not stop talking. I couldn't get a word in. So I'm like, this time I'm starting. All right, we'll see if you can.
It's good. I'm done.
So automation, pen test automation was like this thing that came out. And everybody was like, oh, come on, you're not going to be able to automate pen testing. That's ridiculous. And then we saw this different implant technology like Caldera. You might have seen that before. That's from MITRE ATT&CK. An implant can be, it's subjective. We assume breach. We assume that your organization has been compromised. And we put this little agent, this little service that runs on one of your systems. And it can automate the process of trying to elevate its privileges, laterally move, and pretty much act like an attacker. And when they first came out, they were pretty bad, as you would expect. And as time goes on, it gets better and better. And these things become quite effective. So we want to understand where this, limitations are, what they're good at, what they're not so good at. So continuous purple teaming, I'll give an analogy here, which is, what do I want to say? So years ago, I was at Black Hat, and there was a presentation done by someone called My Instrumented Life. And I was kind of curious about what this talk was going to be about. And the individual started talking about how when you get up in the morning and you turn on the radio, it knows what music you like. It makes recommendations. You turn on Netflix, it knows what kind of movies you like, makes recommendations. You go to the coffee shop down the street, the barista knows what you like because we're creatures of habit, and everything's like instrumented and being monitored. With the whole adversary emulation and purple teaming pipeline, again, another thing that's subjective, and it can be small, it can be large, but you want to instrument systems, have sensors on them, detection rules on them, so that they can detect bad actors, bad activity. Attackers run commands that are typically indicative of someone who's up to no good. Even something as simple as, who am I? ID on a Linux box. That's not something most people run all the time. But an attacker will do that and then a bunch more that together you can say that looks like someone who's not up to anything good. And we can start building profiles, and we can have, again, the detection rules. We've got all these different logging facilities and agents coming into our SIEM. We got normalization going on, and then we put everything into a nice format. We get it onto a SOC dashboard that is tuned to, of course, look for this type of negative activity, which is indicative of an attacker. And one idea I like that I heard a long time ago is we can have these allow listed systems out there that we know are going to constantly have these simulations running. And that's all about testing to make sure that the pipeline works and it's not broken. So that the individual in the SOC who's got these dashboards up, they know that this one particular dashboard is the simulation that's always running, and we want to be able to detect those things. And if we then see similar activity on a system that's not one of those intentionally representative systems out there as part of our pipeline, we know that, hey, this probably is something we should look into. And you've probably seen as well, Tier 1 SOC, a lot of that's been automated by this point. And Eric will talk a bit more about that coming up. You get into Tier 2, obviously human intervention is often needed at that point, and you get up to Tier 3 where you get into response. But it's all part of that continuous purple teaming. So the continuous part, if you didn't catch that, is we can run these simulations periodically just to make sure the whole thing works. And then if we see it on a system where that shouldn't be happening, we can, of course, catch that. You probably heard of things like SOAR and Tines and other ones where we have these wonderful dashboards where we can go in and we can run these different simulations. We can say, I want to as I mentioned before, APT this, APT that, and we can do adversary emulation and simulation just to make sure things are being detected the way that they're supposed to, that the sensors are working, that this data is being collected properly and getting onto a dashboard properly. So we constantly doing this in an ongoing manner. So we get into 2. That was a bit of a refresher and such from last year and kind of talking about what we covered and definitions. Now we get into a bit of the problem statement. So T1003.001, you can't memorize all this stuff, right? But that one in particular is credential guard, right?
Yeah, credential dumping from LSAS. So there you go. Anyone knew that? Now all of the hands, right? Okay.
So LSAS is the Local Security Authority subsystem. There is this tool out there that I'm sure lots of you have heard of called Mimikatz. Mimikatz is an amazing tool that had the ability to inject itself into the LSAS process and retrieve the clear text credentials out of it. So when you log into a Windows system, LSAS process is what stores your credentials from the SAM database originally from the registry. Okay, so if we get onto a system, we can run Mimikatz, steal your credentials, and now we're able to do all the things, right? So since this was being abused so much, I believe this is true, but don't hold me to it. Microsoft came out with something called VBS, Virtualization-Based Security. And what that does is, so imagine a typical system in the old days, right? You've got a kernel, you've got the user land area. So the kernel is the brains. It is what controls the hardware and manages access to hardware via drivers and such. And then users live in the Ring 3 user land application world. Just very simple concept, 2 rings. Then they come up with this fake ring called ring -1. And ring -1 says you shim in between the kernel and the hardware. Now you have a hypervisor. And the hypervisor controls access to the hardware, memory management, virtual disk, all of that. And then you can run multiple operating systems now. So what Microsoft did is they created something called a secure kernel instance. So it's a second kernel running, and something called secondary level address translation. And then there's, in user land, something called trustlets, or isolated user mode processes. And the LSAS process, that's the one that we exploit with Mimikatz to steal the credentials, that is now moved. I mean, it's still there, but it doesn't do the same thing. It's been moved over into the secure kernel instance, and it's called lsaiso.exe, and it's encrypted. So if an attacker runs Mimikatz, they're not going to get anything. And the only way that you can get over into the real LSAS process to get the credentials if you need them is by going through the broker that goes through the hypervisor and then back down again. So that goes back to the example I was saying. This is a good one to explain kind of the concept of purple teaming and offense informs defense. What we can do in a lab is have a student go in and we can say, run Mimikatz and hack this system, get the LSAS process, blah, blah, blah. And they do it, like, cool. Now let's turn on Credential Guard. Let's run Mimikatz again. And now you get to see that what you did has now broken that tool or made it so it's not useful anymore. And you're improving these things together. So this is just an example of one. And in this example on the slide, we're saying, well, there seems to be a public sigma rule available for it. So we're not getting a detection. Why aren't we getting a detection? Well, because we don't have a rule for it. So, okay, we can go manually then, implement a rule, check to see if it works, make sure it works. This sounds very slow and manual, as I've been saying. So we want to be able to go in and then, of course, automate that. And that's a lot what Eric is going to get into here in a moment, talk about the automation of this using LLMs and AI and such. So I'll let him kind of jump in here for a bit.
Thanks. So I like to make jokes, so I'm just going to do it. So it's out of the way, right? Just one. It's like, how do you deal with a depressed JavaScript? So what do you do if JavaScript is depressed? You console it, right? Oh, right. So I
don't make jokes.
Yeah, this is to each their own, right? Can vanilla ChatGPT generate detection rules? So as Steve mentioned, okay, it's nice to run, for example, these TTPs, and we have a look. Okay, we have no detection, right? We try to dump credentials from LSAS. That's nice. no detection, it's less nice. So we can start looking at Sigma, as Steve mentioned, see if there's a public, Sigma is a public repository for typical detection analytics. So it's community driven. The whole point is we could try to figure out, is there already a detection analytic available? If yes, great, I can get it. I can then try to implement it on my system and check again, do I now get a detection, yes or no? Now, sounds like a lot of trouble, so why not just talk to just a vanilla ChatGPT, like the online version, just ask it, hey, do you have a detection rule or a KQL query for T1003.001? Now, for those of you who would be familiar with this, that detection rule that it's coming up with, it's basically event ID 10. Typically, if you're looking at Sysmon process access, right, it's basically a process trying to access the memory of another process. It's opening a handle, if you will, and it's looking for target image elses.exe. It's not bad. Makes sense, right? It's gonna catch what you're looking for. Problem is that it's gonna give you some false positives as well. So it's kind of like, yeah. It's overall, if you look at the effort you have to put in to get it, it's not bad, right? You've got something. So so that kind of inspired us to say, okay, how far can we get with this? Let's really try to build more. So we had this pipeline that Steve walked through, that we actually presented last year, and we said, let's go a bit further. So we're gonna leverage a SOAR platform. So security, orchestration, automation, and response, right? That's what SOAR stands for. And we're going to have it execute a series of TTPs through a BAS tool, like a breach attack simulation tool. Now, then we're going to review in the SOAR tool, of course. The SOAR tool runs the TTPs. So it's the one who instructs, for example, your Caldera, your AttackIQ, or whatever BAS tool that you're using. It's instructing it to run a certain TTP, a certain technique. Now, it knows, of course, that it instructed that BAS tool to run the TTP, and then at the same time, it just starts waiting and it starts listening to, for example, EDR alerts coming in, SIEM alerts coming in. That's the whole point. Everything is connected to the SOAR platform. If it gets a detection, it knows on one of those test systems, as Steve mentioned, good, we have it. We've covered it, right? We have a detection for that TTP. Nice, that's good. Check in the box. If we don't have a detection, next step, and that's new, why don't we immediately try to interrogate an LLM to propose a suitable detection analytic? So why don't you, let's try it, right? Let's see, can you give me a detection analytic for this specific test? Then, of course, we want to evaluate that analytic a bit. You'll see in the demo, it comes back with some interesting things. Are there any detection engineers in the room? One, two, few. So reasonable. We are not going to automate you, don't worry. We tried, it didn't work. Jokes aside, removing the human from the loop is practically impossible at this point, but we'll see, you never know, right? But what we can do, and that's the nice part, we can really make your work much more effective, much more easy, and we can really improve the output that you can get. So you can always buy us a beer, right, when we're out. So. What we do though, we then review, fine-tune that analytic, and then we test it again and to see, okay, does it work, right? Fully automated. So we can really keep on, the whole point of this is automate as much as possible to see if we can really make this very effective. So here's an updated architecture. We would have our SOAR platform, and we've got our detection engineer or operator, however you want to call them, interact with the SOAR platform, use the SOAR platform to instruct a certain TTP to be executed by the BAS tool, right, the breach attack simulation tool. And then, of course, when you notice that there's detection gaps, if you don't have detection for a certain test, you would actually interrogate an LLM, ask it to generate a rule, deploy the rule, test it, validate, and so on. Right? The whole goal is to really build an entire framework that can be used by an operator or a detection engineer to speed up detection engineering. All right. So can we build this? We just built this in a test setup, and we'll actually run through a live demo in a second. It is recorded though, but I have a perfect excuse why we recorded it. Because we had to cheat. No. We didn't have to cheat. The thing is, we're using a cloud-based SIEM like Sentinel, for example, which is honestly, you could use another SIEM instance as well. The thing though is, it sometimes takes a while for the alerts to get in. And that's of course something that we don't want to just be waiting here for events to come in. So at certain points, you'll see that we speed up the demo a bit. But what's the point? We actually used this setup. You could, of course, swap that out with your own technology. We used XSOAR as the SOAR platform. If you want to use logic apps, if you want to use Tines, as Steve mentioned, that's fine. Go ahead. You can implement something very similar using any other automation or a SOAR tool if you would like. And we use Sentinel as the SIEM platform, right? Again, there you could swap that out with Elastic. There's many different things, whatever you want. not just Elastic in Microsoft. I do have a sweet spot for Elastic, but okay, I didn't use it here because Sentinel really works nice. It's very easy to just. Caldera, right? Again, there, it's a BAS tool. I do have a sweet spot for Caldera as well. Why? Because, well, I'm European. And you say, well, it's built by MITRE, and that's American, right? Yeah, but I'm European, and we're a bit cheaper. So we like free tools. So Caldera is great. I like it a lot. Don't expect miracles, but honestly, you can never expect miracles from anything, right? But you could swap that out as well with a commercial BAS platform. They were on the slide that Steve mentioned. There's the Picus, Attack IQs, all of those. You could, of course, swap that out. Same thing, right? They have an agent running on the system, and they use that to execute TTPs. So again, very interchangeable, this whole architecture. All right, so what does that look like? Step one, in our Caldera or our BAS tool, we're basically going to create what we call an adversary. So what is an adversary in Caldera? It's just their terminology. Their terminology of an adversary is basically, it's basically a bunch of abilities, right? So what's an ability? An ability is a TTP. So a specific technique that you're going to execute, that's an ability. If you group them together in a whole emulation plan, that's what they call an adversary. Perfect. Then you could actually run that operation through SOAR. You could say, look, okay, here's the SOAR dashboard. We create a new incident. Eric, the goal is to prevent incidents, not create them. Fair, but this is just the SOAR terminology. In XOR, for example, everything is an incident. That's just how it rolls. So we're creating an incident, but the type of the incident, it's what we call an, I don't think it's here on this screenshot, but you'll see it in the demo. It's an adversary emulation control incident type. That's what we build, right? And we'll share a little bit about how we build it, but the whole point is we create a new operation to run. Then you can see, okay, do we get detections back? Again, I'll show you this in a live demo in a second, but just walking through what you'll see so you know what's going on. You can see, obviously, for one of these typical campaigns, you see some commands there like who am I, host name, all of that. Typical reconnaissance commands, of course. You can see that you don't get detections for those first two, which is probably, yeah. As Steve mentioned, you don't expect John from HR to be running who am I on a system, right? Typically doesn't really happen. But creating a rule for just looking for who am I execution is going to be a bit noisy. Probably if you're doing detection engineering, what you're probably more looking at is like a threshold, and if you see 5 of those reconnaissance commands being executed in 1 minute or 2 minutes, it's probably something to look for, right? So a bit, yeah, there's no detection just for someone running who am I, which makes sense. But there are some detections coming back out of the box, so that's just really a standard stack setup.
This becomes important too, because my brain goes immediately to it when he was talking about who am I is attackers, hackers, pen testers, whatever, we need to do a lot more living off the land these days to go undetected, which means use tools that are already installed, use commands that are allowed. Remember when PowerShell came out? It got abused real quickly. So then they had to come up with what good PowerShell looks like, what bad PowerShell looks like. So I was gonna ask you, like, false positives, can you go into that a bit?
Yeah, we actually have, I think it's on the next slide even, we have some insights on false positives and how we deal with them. We actually built into the platform, which is nice, into that framework, a mechanism to also test the use case or the detections. So if we have a detection that we generate, and you can see there proposed KQL queries by our ChatGPT instance. So it's saying, you want to detect who am I? Well, here's a potential KQL query for who am I. It's pretty brittle, as you could see, right? If you look at it, it's just saying, you want to detect who am I? That's fine. Here's the rule. It's basically 4688. It's command line. It's a command line execution, if you will, and it's just looking for who am I. It's not wrong. It's just very simple. So, but okay, nice. It's there. You can then fine tune. Again, the goal is you will need humans in the loop. That's very clear. But indeed, false positives. How do you deal with that? I think this is a really nice slide to show a bit the value of what we're building, or what we have built. At first, you can see an initially generate detection rule by ChatGPT. So very simple. It says, okay, we can look for who am I, command line execution, very simple. You can see that it says valid query false. Interesting. It actually proposed the rule or a KQL query. I tried to push it onto Sentinel, but it failed. Didn't work out. So we fetch that error, right? Our SOAR platform fetches the error, and it says bad query, blah, 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 blah. Look, we're lazy. So what do? We just take the error, push it into our LLM model, and say, hey, you gave me a query, but it doesn't work. What's up? It basically came back and said, okay, wait, we can fine-tune that query a bit. It's basically saying, but the process command line does not exist in the security event table, which is, by the way, a default table in Sentinel, but it's a detail. And it just gives you a bit of background, but it says, try this. Nice. So we try the corrected query, then it actually works. So see, it's self-learning. It's amazing. It might yet replace us, right? Who knows? But then we can see valid query, true, so it works. And you've got 29 detections. So we also immediately look at, okay, but how many detections do you get? Now, if you get 29 detections over the last 7 days, it's probably not a very solid rule, right? So you don't also feed that information with, okay, we have X amount of detections. What do you think? And then it also gives you a verdict on the query. So the LLM also says, okay, based on that, that's quite a number of detections, so you might have to fine-tune that a bit more. So we built that all into the whole system, which is interesting. So a bunch of prompts that we used at the moment, and they can be fine-tuned as we go. That's, again, also, we made it very adaptable, so we can just update those prompts, change them around. We had to do some messing around with them as well to really understand what gives you the best success, if you will. The first one is really to create an initial detection rule. You can see we use some variables there. So we specify, for example, the techniques, of course, that we're looking for. That makes sense because it needs to know what it needs to generate, right? But we also give it, for example, that prompt on how to fix query errors, stuff like that. And of course, reviewing whether it's accurate enough or not. Right, finally, demo, right? Let's have a look and let's see if this actually works. Because it's nice to make slides and to talk a bit, but does it actually work? Fingers crossed. Ooh.
Demo guides are going to get you one way or another.
It's even with the recording. So there we go. This is our XOR instance, new incident, as we said. It's going to speed up at various intervals when there's some waiting to be done. So we're going to... I actually used the purple color for my font, but it looks blue on the screen. See, purple, team purple, but okay, that's fine. It doesn't... It works. So create a new Caldera operation as an incident. We're just configuring it. We're putting quite some default stuff in there. We're not really gonna. This is really a standard Caldera integration of XOR, so we can just create. We can use. It's using the Caldera API, of course, to talk to it and to create a new incident. It's good. All right. So new incident created. So we're opening that up just to review what's going on, and then you'll see that. Hopefully, I say hopefully, but I know what's going because it's recorded. It's nice, it's very comfortable. So here we go, review the operation summary. So it's running and you can see the different techniques that it's running. We currently have 0 detections, which is honestly not that great. It's pretty bad, but it's still running, right? That's the whole point. It's still going on. So again, you need to wait a bit for all of the rules to trigger and to actually get the results into XOR, so that makes sense. You can see here the detailed commands that we're executing. Now this is just a built-in adversary in Caldera, right? So we didn't specify our own abilities. This is just standard, straight out of the box Caldera, just to see what happens. So we're reviewing the operation details. That looks good. All right, so let it go, and then we just we cut there for a second so that we have the events. You can see that we have 2 out of 7 detections. That's just standard without any changes. So we can see that, okay, it's not bad. Maybe we can have a look at that. Zooming in on the actual operation result logs there, so you can see for every one of those executions, okay, false true, false true. It also links to what they call detected incidents. So the real incidents, like the security alerts, they're also mapped there, which is nice, so you can actually go and investigate them. Now, in that same workflow in XOR, you can now also look at the prompt that we're using, so we can review it, you can customize it. So that's nice, again, designed to have it work with the detection engineer, right? To really have them look at, okay, look, you can fine-tune this. For example, here, the Sentinel table to use, we're just gonna use a security event. It's default, don't worry, that's fine. But more interestingly, we can, for example, fine-tune the adversary emulation control use command. What does that mean? This is a bit cheating, but we wanted to test it to see if it works or not. You could set that to true, and then it will actually tell the LLM what exact command it ran for the detection. Does that make sense? So it's just testing it out a bit, what gives you the best bang for your buck, if you will. You could also just adapt the entire prompt, of course, right? It's there, then we just select the techniques, fine. Again, take into account, bear in mind, all of this is just, what we're trying to do is make an easy interface for detection engineers to just automatically run these TTPs, get them through, and review and validate detection rules. So select time range for query evaluation. We put it on 30 days. It means that it's going to look for 30 days of history to see if it's getting alerts. And then wow, a work plan. So this is how they sell you the SOAR platforms. Turns out there's a lot of code actually in the backend that you have to write, which is more unfortunate. But this is the actual work plan where you can see the different steps. It's running through that. So it's ongoing. Again, give it a bit of time. So today I learned from my esteemed colleague Dan, who's in the audience, not today, yesterday, what's it called? The movie editing software in Windows. It's pretty nice. Clipchamp, yes. It's amazing. So you got the... I missed my GIF, but I added a small GIF because the rules are pretty brittle, as you would say, right? They're not perfect. What it's doing is, you're executing that, so I'll give you a command line execution event for that specific command. So what you likely want to do, fine-tune it, right? So that's also implemented in the whole flow. You can just say, okay, but let the detection engineer customize the queries there. So update the proposed queries. They're not pushed into Sentinel yet now. It's just using those KQL queries to see if it's getting results or if it's getting hits. So you can validate them again. So it's going to update the results to show you, okay, do you get more or less? Again, the whole idea is you can keep on going in this specific field. Or in this specific, let's say, tool, if you will. It's all from XOR. And then, of course, you can review the updated results to see how you're doing. All right. Good. It's not bad. Yeah, it's going to go a bit further. So now we're pushing the rules actually into Sentinel, but just for timing, because there's a few more things I want to show and discuss. So you can then push the rules, of course, into Sentinel, and you can see, okay, does that work? Does that help us? A few conclusions maybe on this. Atomic TTPs, yes, you can automatically execute them, right? It's simple, and you should automatically do that periodically. These whole models, they can be a force multiplier, absolutely, but a lot of them are quite brittle, right? If you just use vanilla ChatGPT, the detection rules that it comes up with are relatively simple. And simple is not always bad, but in this case, it's often a bit too simple. Because, for example, take LSAS dumping from, credential dumping from LSAS. You don't want to look for Mimikatz, right? You don't want to look for someone running Mimikatz. What you want to look for is someone opening a handle to LSAS. So the first one that I showed, that's actually smarter because it's more behavior, but it has the tendency to go into, but we'll just look for the command being executed, and it's a bit more brittle, if you will. So what we did next, we said, okay, but let's increase the capabilities of this thing, and a few things that you could do. You could, for example, use RAG, Retrieval Augmented Generation, to basically allow the LLM to parse, for example, to read through PDFs, if you will, to really fetch information from a PDF, from an HTML, from something that you give it, to see, can it, for example, interact with the Caldera API? Can it consume or look at, for example, Sigma rules, right? You've got Sigma repositories, so it doesn't have to come up with everything itself. Can it parse PDFs, for example, to know about TTPs and to actually automate that section as well? Enter AI agents, if you will. Now, there's actually another talk coming up on Wednesday where we discuss this in a bit more detail. So if you're interested in AI agents, highly recommend it. Shameless plug. But what's important, we actually use this here in our overall framework as well to say, okay, but how can we make this smarter? Because the whole vanilla ChatGPT thing, that works, right? But it's not great, as we've seen. So for example, could we create an agent which acts as a threat intel analyst? We feed it the PDF and we say, look, give me all of the different TTPs basically in this PDF, right? Because the next step, once we have that, we could say, oh, nice, we have a list of TTPs. Now let's design abilities in Caldera. Let's execute them. And then for all of the gaps, let's try to figure out if we can have detection rules. Because in the first demo, the one that I showed you just now, we only have the right part, right? Which kind of works, but it's a bit silly. But idea here is, can we now go a step further and look at, again, have our detection engineer in the loop, work with the SOAR platform, but also work with the LLM models to then start parsing, for example, PDFs to extract TTPs, to generate abilities in Caldera, to test those TTPs, and then actually try to generate detection rules. It's like, this guy's a maniac. Ta-ta! Ultimate results. So that's the idea. Can we just give this evil empire of agents a PDF, like a threat intel report, and say, go? And what I want as output is a dashboard with observed detections for TTPs in that report, and identified gaps, including even suggestions for those gaps. That would be a pretty nice outcome, right? Because then, you know how management comes up to you often and says, oh, look, this new campaign, how are we doing, right? What's our posture like against this? Well, if you can automate it, that's pretty nice. We've got a robot. Yeah, we built it. So here we go. Demo 2. Don't worry, we're perfect on time. Almost finished. As they overrun. So what do we do here? We're actually going to have it download TTPs from an HTML report. I need to get used to the spacebar. Yeah, it's good it's running. I just want to pause it for a second. So what do we do here? We're actually referring an HTML TI report. So it's basically a relatively recent campaign from end of April. And you can see that the first agent, they're popping up saying, okay, you have a TTP. You have a report for me, an HTML report that I can look into and where I can extract TTPs from. Right? First one kicks in and says, okay, let's have a look. Let me start getting TTPs from that specific report. Excellent. So then it goes on, says, okay, that's fine, I got that, I read that. Boom, boom, starts doing stuff. Zoom in. So what does it do? Indeed, it can extract the TTPs from the report. So it's sufficiently smart to say, it's an HTML file, that's fine. I can just run through that and I can get all of the different TTPs in that report. Next thing you want to do, of course, is map those TTPs to abilities in Caldera. Remember, an ability in Caldera is nothing more than a TTP to execute, right? But we want to figure out, do we already have those TTPs in Caldera so we can just execute them? Yeah, this. We just let them do their thing, don't worry. We might not get replaced yet, but let's just let the LLMs do their magic. You can see extracted TTPs are now mapped to Caldera abilities, so it knows, I have TTPs, I'm going to map them to abilities, and finally, I'm going to create a new Caldera adversary profile with those abilities. Does that still make sense? Right? So yeah, they just continue processing, let them do their thing, it's all fine. And then, of course, what happens, rinse and repeat, and look at the speed now, don't worry, this is on purpose, because now it's the exact same thing. So it created a new operation in Caldera, which is ready to go. Now from XOR, you can create that new, you can use that new operation, which is using that new emulation plan based on the TTPs in the PDF, right? Without human intervention. So all of that got automatically generated, giving you a nice ability to immediately test that now, and to, honestly, you could do that every month, right, for the foreseeable future, because it's fully automated. And that, I think, is quite beautiful. Of course, you can change the prompts, you can adapt them, and you can keep on going. Same thing. I'm just skipping ahead a bit. Deploying the Sentinel rules. There we go, get them all in. And then, yes, all deployed. So very similar. I just cut my demo a bit short, but does that make sense? All right, good. So, where does this leave us, right? Where does this bring us? A couple of conclusions, and then we probably have maybe 1 or 2 more minutes for questions. Yeah, I know. Then you'll have to get us in the hallway. But what's the conclusion of this? I think the first one, you cannot automate red teaming. That's pretty clear. So if you're doing pen testing, don't worry, your job is not yet in danger. Not yet, never know. But it's important to use these LLMs, I think, test them and see how they can be useful. Our conclusions for this specific type of event, I think, yes, you can do some very impressive things. Yes, you can optimize your output as a detection engineer, because some of the more menial tasks, taking a PDF, extracting the TTPs, mapping the TTPs to your BAS tool. Do I have those? Can I run those techniques in my BAS tool? Then, well, doing the whole orchestration around it. Can I now run that whole operation? Can I also review all of the detections? Can I create a dashboard? All of that can be very easily automated. The moment, of course, it comes to fine-tuning the detections, that's where you still need a human in the loop. But honestly, I think this is pretty nice because it gives us the ability to, if you have a smaller team of detection engineers, they can get a lot more done, of course, when you implement a system like that or a workflow. That's it.
Yeah, I'll just summarize too, the whole concept of the agents serving these different roles. Like I'm doing that a bit at home right now with the whole idea of patch diffing, where Microsoft comes out with their patches on Patch Tuesday every month. And it's been a manual process in the past where you download the patches, extract them, diff them, identify the vulnerability, determine if you can weaponize it, and then try to weaponize it and exploit. Very, very time consuming. Automation of the patch diffing and identification of what kind of vulnerability it is now and mapping just the concept of these agents and having it help you, like Eric said, especially if you have a smaller team and such, is where everything's at and going right now. It's beautiful. So thank you so much, and we will happily chat with you out in the hall, but thanks.